So the first thing I want to do in this equation to figure out what x is that I'm going to subtract 3 from both sides. And when I'm doing that, I'm using the subtraction property of equality, which basically means that if I subtract a number from one side of the equation and I subtract the same number from this other side of the equation, everything stays equal, everything stays balanced. Now, when I subtract 3 from that positive 3, the only thing I'm left with on the left side of the equation is a 2x. Now I'm going to divide both sides of my equation by the coefficient of x, which is 2. And when I do that on both sides of the equation, I'm using the division property of equality. Similar to the subtraction property of equality, if I divide one number on one side of the equation and divide the same number on the other side of the equation, everything will remain balanced, everything will stay equal. Now my 2 in 2x divided by 2 basically becomes a 1, so I just have 1x, and 4 divided by 2 is 2. Now it's always a good practice to check your work. So I'm going to start by rewriting my original equation, which was 2x plus 3 equals 7. Now I believe that x equals 2. So what I want to do is I want to substitute 2 into my original equation. So I'm going to get 2 times 2 plus 3 equals 7. So if 2 is a correct solution, both sides of the equation should equal the same thing. So I get 4 plus 3 equals 7. 7 does equal 7, and I have a correct solution. So the first thing I want to do in this problem is that I want to add 3 to both sides of the equation. And I can do that because of the addition property of equality, which basically says if I add the same number to both sides of the equation, my equation will remain equal and it will remain balanced. Now I'm going to multiply both sides of my equation by 4 over 1, which is the multiplicative inverse of 1/4. I'm using the multiplication property of equality to make sure that my equation stays balanced, it stays equal, even though I'm doing something to both sides of the equation. When I multiply 1/4 times 4 over 1, I'm going to get 1 whole, which means I'm going to just have 1n, or just n. Now when I multiply 4 over 1 times 28, or 28 over 1, I'm going to get 112. What I want to do is make sure that what I think my answer is going to work in this equation. So I'm going to start off by rewriting the original equation. And since I think that n equals 112, I'm going to substitute 112 for n in my original equation. So I'm going to have 25 equals 1/4 times 112, and I'm just going to write over 1 minus 3. through the process of cross-simplifying, I'm going to divide both 4 and 112 by 4. And now I'm going to get 25 equals 28 minus 3. I'm going to keep simplifying. I get 25 equals 25, which is a correct solution. This equation is a little bit different because I have a negative coefficient to my variable x, but I'm still going to go through the same process. The structure is going to be the same. So I'm going to subtract 6 from both sides using the subtraction property of equality. Since my coefficient of x is -3, I'm going to divide by -3. So I'm using the division property of equality. And -3x divided by -3 will be a +1x, or just x. And then 15 divided by -3 is -5. Let's go ahead and check my work to see if the solution x equals -5 is true. So I'll rewrite my original equation. 6 minus 3x equals 21. And since I think x is equal to -5, I'm going to substitute it for x in my equation, which will now get me 6 minus 3 times -5 equals 21. So using the order of operations, I need to multiply -3 and -5. So I get 6 plus 15 equals 21. And sure enough, 21 does equal 21.